Okay, morning to all of you. Okay, now we proceed with the chapter 7b known as basic chromatography, and we'll focusing more on planar chromatography, which is paper chromatography, and also TLC, thin layer chromatography. Okay, so in this topic you will learn about planar chromatography, which is paper. Second one is planar chromatography also for TLC, and advantages of TLC over paper chromatography. So for the third part is very favorite questions. Okay, so you need to take into account this part, very important. Only this is favorite question. Okay, as I said that before, chromatography, okay, partition, so involve a partition phase which is a liquid, mobile phase is liquid, while adsorption stationary phase is solid, mobile phase is liquid. So under partition we have the paper chromatography, which is the stationary phase for paper chromatography is liquid, mobile phase is also liquid. While for adsorption, so we have column. Okay, column absorption process occur for column and also TLC, because TLC stationary phase is solid, which is we will coated the glass with a surface coated with for the TLC, for the reaction to occur the separation to happen in that solid surface. So TLC and PC is category under planar chromatography because the absorption process known as, after this I will tell you later. Okay, for planar chromatography, for paper, a sheet or narrow strip of paper serves as a stationary phase. As I said, that paper chromatography is a solid support, and then we will have the stationary phase, which is water, attached to that solid support. While for TLC is a thin film of a stationary phase, which is we will coat it on the solid glass, normally in glass, on glass plate or a plastic or metal sheet. So normally we want to make sure that thin film will coat it well in the glass plate or plastic or metal sheet. So normally we use the mechanical strength with a binder such as calcium sulfate and so on. So proceed with this paper chromatography. For the purpose, use the technique of paper chromatography to separate a homogeneous mixture into its individual components. Uses is separation and identification. So paper chromatography is very cheap, fast process, and very sensitive and wide uses. So this is the advantages of paper chromatography, because where the price is, the process or the price is quite cheap, so we can reproduce of the results. We will replicate the results a few times. But the problem with this paper chromatography, it has a reproducibility of the result is very low, cannot withstand corrosive chemical. The stationary phase, as I said, is a water molecule. So when you deal with a water molecule, meaning that it deals with a polar component, which is trapped or coated or supported in the paper strip. So normally paper strip is made up of cellulose fiber, so it contains of a very high of hydroxyl group. The trapped water content of H2O contain also OH, so act as a stationary phase, and the filter paper itself is a support. Mobile phase is an organic solvent such as mixture of ethanol and water. The mobile phase liquid will be less polar than stationary phase. Since your stationary phase is already polar, so your mobile phase should be less polar or non-polar than stationary phase. So the principle of separation difference in the partition coefficient of component of a mixture between two liquids. Okay, paper chromatography is a type of partition chromatography. Paper chromatography also liquid chromatography, as I said tadi. Okay, you can see from this. This is the principle and technique of PC. So first, what you should do, yang pertama adalah development of, so the second one is development of chromatogram. The first one, you need sample preparation and application, which is a sample is dissolved in a volatile solvent. The sample is spotted using the capillary tube. on line previously drawn on the end of the PC. So you need to draw a line with a pencil, because pencil is content of carbon. It will not react it not involved in the reaction, because carbon is made up from is also is an organic component kan? So the spot should be dried first, and then before the second time is to make sure that the diameter of the spot is less than 5 mm. So what you should do, bila spot sekali, you gonna dry, kipaskan dia atau kibaskan dia tu, bila dia kering, and then you spot once again, in order to make sure you will have an enough amount of you punya analyte untuk berlakunya separation. And then after you draw, and then you dip, you dripkan you punya paper chromatography tadi tu in development solvent, tapi bawah daripada origin line yang you draw tadi. Okay, so and then kita tegakkan dia lah. So then development of chromatogram, all spots are allowed to dry first before it's dipped into the development solvent. As I said before, the development tank should be closed so that the development chamber is saturated with the development solvent. Dalam tu nanti bila ditutup, dia punya reaction akan berlaku, so dia akan complete, so dia akan touch pada semua permukaan paper awak. This is to make sure that the spot move upwards smoothly by capillary action without interruption. So for TLC and also paper chromatography, the action that happen is a capillary action. Okay, and then the solvent will carry the various spot upward at different rate until the solvent from front is about 3/4 of the PC. The paper is removed from the tank and the solvent front is marked. So you kena tunggu, and then bila dah mark tu, you kena biarkan dia kering betul-betul, baru you boleh proceed for the next stage untuk buat calculation. Okay, this is things separation that happen. Then the last part is you need to measure retention factor, RF value. So you need to have the distance solid or analyte move over distance solvent front move. So solvent front from the origin line until solvent front, dapat A over B. B over A, you will have the RF value for B ni, dalam kes ni warna biru lah, biru spot ni lah yang travel ni. Tapi kalau banyak-banyak lah nanti you dapat RF A, RF B, RF C, depends on you punya berapa banyak analyte yang ada. And then by comparing the RF of sample to that of standard, the identity of the sample can be determined. So that's why bila kita buat spot ni, kita kena buat spot satu untuk standard, satu lagi untuk you punya sample mixture. So then macam ni, contoh macam ni, you nak detect you standard awak, contohnya standard standard air contohlah air sirap kan, contoh air sirap. So dalam tu standard dia ada dua color, which is warna merah biru dan kuning. Tapi yang punya sampel awak tak tahu sampel awak tu ada contain of apa. So tapi dia mungkin nak tengok ada tak sampel sirap dalam tu, dalam awak sampel. So you masuk, you dotkan dia. Bila berlaku separation, nampak ada dua warna ada keluar kat situ yang boleh mewakili. So itu cara kita nak detect dululah sama ada warna sampel tu adalah macam mana. Okay. So this is an example of calculation of RF value. So very simple, 2.1 bagi 2.8 dia dapat 0.75. So if you can see from the listed information there, so value below 0.1 is considered poor. The spot are too close to origin. Value of 0.1 until 0.8 is good, and any other spots, impurities or other active are resolved from each other. Above than 0.8 is very poor also. Spot may be too broad or distorted. So meaning that this RF value for this sample 0.75 is in a range of good values. So you need to try this. Okay, I give you this example, and then I have listed already the solution. Okay, for RFA, RFB, RFC. So when you calculate the RF for A, B, and C, you will have 0.2, 0.6, and 0.8. So kalau tengok sini, siapa yang kalau ni dah namanya paper chromatography kan. So paper chromatography maksud dia punya stationary phase adalah polar, meanwhile you punya mobile phase adalah non-polar ataupun less polar. So bila less polar, maksudnya kat sini A adalah polar component lah, sebab dia travel paling sedikit sekali. Meanwhile B adalah yang less polar, yang C adalah least polar. Sebab dia mempunyai karakteristik of mobile phase. Okay, for thin layer chromatography, a type of absorption chromatography where the mobile phase is liquid and the stationary phase is a glass plate, a thick aluminum foil or plastic sheet coated with a solid absorbent such as silica gel, alumina or cellulose or kieselguhr. So ada 4 kat sini yang common yang digunakan pakai sebagai solid absorbent yang kita coated atas glass plate tersebut. Okay, so you need to remember lah 4 ni. So di antara 4 ni ada yang satu less polar ya. Yang lain tu semuanya adalah polar component. Thin layer chromatography is one of the type of planar chromatography. In this technique, a small quantity of solution of mixture to be analyzed is deposited as a small spot on TLC plate, which consists of a thin layer of silica gel. So as you can see here, this is solid absorbent of TLC. So for silica gel can be obtained with a small additive of calcium sulfate and fluorescent indicator for separation of acidic and basic substance. So nampak dia punya function. Kalau untuk acidic and basic substance, we preferable to use silica gel. Meanwhile for kieselguhr, less polar than silica gel, less strongly absorbent. So maybe yang ni adalah less polar, so kita boleh guna pakai untuk sampel. Kita boleh tukarkan lah, maksudnya mobile phase awak polar, awak punya solid absorbent adalah kieselguhr ni, dia less polar. Alumina degree of absorption depends on its pH and the amount of activation for separation of basic substance only. So suitable for basic substance for alumina. Meanwhile cellulose available with or without binder for separation for polar substance. This one. TLC also same, tak tahu pun sama principle separation dia. Compound depend on the attraction between compound and those of the solvent and the stationary phase. The more strongly a compound is absorbed, the less distance it can travel up the plate. If the mobile phase is polar solvent and stationary phase is non-polar, the more polar compound is more soluble in the mobile phase, so it will be travel faster up to the plate. The less polar compound will strongly absorb to the stationary phase and will travel slower up the plate. If the mobile phase is a non-polar solvent and stationary phase is polar, the less polar compound is more soluble in the mobile phase, so it will be travel faster up the plate. The more polar compound will strongly absorb the stationary phase and will travel slower up the plate. So the process of to use this thin layer chromatography, first of all, what you should do is pre-coated TLC plates, okay, which is preparing and activating the TLC plate. Actually, pre-coated TLC plate are available commercially, but the price is quite expensive lah. And then what you should do, the second part is spotting the TLC plate with a sample, and then developing the TLC plates macam sama macam paper chromatography tadi. And then after that, after you finish the reaction, drying the plates, visualizing the substance spots. There is many methods to visualize the substance spot ni. And then the last part is measuring the RF value, meaning that calculation, to perform the calculation. Okay, so why we need to have many types of visualizing the substance spot? Because there is some analyte after separation, dia tak akan appear langsung pun. Dia tak akan appear langsung pun dalam awak punya TLC plate tu tak nampak langsung, tapi you kena visualizekan dia menggunakan beberapa benda lain yang kejap lagi saya akan ajar. Okay, this is how you nak buat preparing the TLC plate. So kalau nak buat sendirilah, kalau ada yang kawan awak tengok video tu kan, dia buat sendiri. Macam ni lah cara dia buat sendiri. Dia tekan, tapi this is step involved lah. So biasa kita guna spreader ni lah. Spreader ni paling bagus sekali, because spreader ni akan maintainkan dia punya ni kepada film thickness of the film tu akan uniform. Compared to kalau kita buat sendiri macam ni, kadang-kadang dia tak jadi yang proper lah. Tapi kalau nak testing awal-awal boleh. Okay, to activate the TLC plate, so first the plate are dried for half an hour, then are heated in the oven at 100 degrees Celsius for another half an hour. Then they are cooled in a desiccator before you use. So a bit crucial jugalah dia punya step ni. So manja sikit kan. So biasanya bila you nak buat this, when you want to use the TLC, so you need to make a preparation dahulu, one a day ahead ke, ataupun buat banyak sikit lah, tak boleh buat satu, takut ada berlaku kesilapan sebagainya kan. And then spotting the TLC plate with samples, quite similar with the paper chromatography, same thing. You can read from this slide. And then developing the TLC plate, this is, you need to prepare the solvent system, which is the mobile phase. So which is first, you can choose any types of mobile phase yang suitable with the reaction. So for example, when you deal with the N-hexane ratio with the dichloromethane 9:1, okay, and then PET ether ratio with the methanol, so boleh tengok dalam list ni, water and ammonia. Mix the solvent well and pour the solvent system into a closed jar. Masukkan dulu closed jar tu dulu, and then by using forceps, place the TLC plate that has been spotted inside the jar. Jangan awak dah bubuh TLC plate tu dulu, and then baru nak letak awak ni solvent, salah ya. So nanti akan berlaku interference lah kat situ. Okay, then this is a method to visualizing the substance spot. So we can use maybe UV lamp, by using UV light, so baru you nampak spot tu muncul. Dia pun manja juga benda macam ni. Okay, and then you can spraying TLC plate with a ninhydrine. Okay, and then you put the TLC plate inside the iodine chamber. Okay, and then spraying the plate with a concentrated sulfuric acid and heat. And then fluorescence indicator, which can be visualized under UV light. So ni penting ya, sebab tahu ni kadang-kadang dia nampak, kadang-kadang yang tak nampak tu kita kena guna pakai salah satu yang ada saya listed here. And then this is the advantages of TLC over PC. So the separation occurs much faster and better. Have a choice between different absorbent, and spots are more discrete. The important part is can withstand with the corrosive chemicals. Okay, without harming the absorbent. So this is things yang baguslah TLC over PC, but the price of the TLC quite expensive lah compared to PC. Okay, and then this is a example of the question, final exam question. Okay, from question 10. Give two application of paper chromatography. You letak lah kat situ. Distinguish between absorption chromatography and partition chromatography. So absorption TLC, partition adalah PC. So distinguish, mungkin you kena distinguish apa yang nak distinguish kat sini. You can distinguish dia punya mobile phase, dia punya stationary phase, and then apa yang sama, apa yang berbeza. Cuba tengok kat situ lah. And then below are the RF value for amino acid in solvent so saya letak sini A, B, C. So with the glycine A, alanine, B, serine, C. So sketch the TLC. This is a common question. Normally they will ask you to sketch the TLC results on a mixture containing glycine semua ni. The baseline to solvent front length equal to 5.2. So kena ingat kat sini, bila nak lukis, kena lukis ukuran yang sebenarnya, bukan ukuran yang macam saya buat ni, saya sketch saja. Tapi bila you buat, you kena lukis dalam bentuk ukuran sebenar. So meaning that pada origin until you punya solvent front travel tu 5.2 cm. So you kena lukis betul-betul balik 5.2 cm tersebut. Draw the chromatogram and label the spot of the each standard and component present in the mixture. So right now you tak boleh simply letak 0.3 paling rendah, 0.56 second, the third one is 0.7. Tak boleh. So ini convert into centimeter juga, sebab dia bagi pada awak baseline tu adalah 5.2 cm to solvent front kan, baseline to solvent front. So you calculatekan dapat untuk RF 0.7 tu you dapat 3.64. So ukur 3.64, dapatkan ukuran tu, tulis betul-betul. baru boleh lukis. Okay, so this is the second question. So you boleh baca dan tengok, nanti kita